All right, hey everyone, good morning. Hope your weekend was well. So, for our last few lessons of the school year, we're going to be going through this unit, sequences and series, which will help a lot if you choose to take BC Calculus. Okay. So, for your aim for today, how do we find the partial sum of a sequence? Um, the do now is given the sequence defined by a sub n is 2n, find the first four terms and also the 103rd term. Okay. All right, so we'll give you a few moments to complete this question on your own, and then we'll talk about it in, let's say, 30 seconds. Oh, your homework, by the way, as you see here, is just to complete the classwork. So I'm want to upload the lesson plan on Google Classroom, so you have the solutions there actually, if you so you can refer to those solutions. Okay, so I'm going to scroll up for the solution now. All right, here it is. All right, so again, the do not asks us to find the first four terms defined by the sequence. So a sub 1, it's going to be 2 times 1, which is 2. Notice here that the first index we use is 1, right? So we start n equals 1. Technically, you could start at 0. That's also common, but normally it would be like 0 or 1. A sub 2 is going to be 2 times 2, which is 4. A sub 3 is 2 times 3, which is 6. A sub 4 is equal to 8. Okay. And then for part B, the 103rd term is, just plug in 103 into the formula, you get 2 times 103, which is 206. Okay. And so here, as you see in the definition that I'll show you next, but yeah, for now, just make sure you have the solution for the do now. They start at a sub 1, and that's the convention that they establish in this textbook, but again, if you remember from Algebra 2, right, the sequence and series unit in last year, sometimes you can start at a sub 0. So, but yeah, I guess for the sake of our class, since we're being consistent with the textbook, we'll start at a sub 1, unless otherwise specified. Okay. Does anyone still need this do now solution here? Okay, if not, then I'm going to move on to the definition. And I think for the sake of time, since the next part is an example, I'll just refer to the lesson plan itself. Um, yeah, actually, let me give you an overview. So we're first going to talk about sequences, and then that'll be followed up by an example here. And then we'll also talk about graphing a sequence, an example of that, and then we'll also talk about recursive sequences and the partial sums of the sequence. So just like some various topics in in this section of our textbook. Okay. But yeah, so here is the definition. Could I get a volunteer to read this, please? All right, we'll go to Asani.
A sequence is a set of numbers written in a specific order, A1, A2, A3, A4 to AN. Each number is called a term of the sequence.
Okay, thank you for that. So yeah, here, they don't really specify the fact that, yeah, so this is like a really general and loose definition of sequence, right? They don't, I guess, by specific order, they mean a pattern as we saw, and they do now. But yeah, so a sequence is a pretty general term, in other words. Okay, but yeah, and in order to like just put more, flesh and bone onto this definition, we'll, look at these examples. And this might, might ring a bell from, because you might have seen this last year in Algebra 2. There was, yeah, there should have been um, a unit on that in that class. So, okay, all right, but let me dive into this example here. So here it says find the first 5 terms and the 100th term of the sequence defined by each formula. So part A is t sub n is n over n plus 1. And then part B, we have r sub n equals -1 to the n divided by 2 to the n. Okay. So the first 5 terms for part A, it's going to be 1/2, right? Because we plug in 1, so we get 1 over 1 plus 1, which is 2. And then we have 2 over 3, and then 3 over 4, and then 4 over 5, and then 5 over 6. Okay. And then the 100th term is going to be 100 over 101, right? All you do is plug in 100, right? So we get 100 divided by 101. Okay, for part B, again, you just plug in 1, 2, 3, 4, 5, and then 100. So for 1, right, we get -1 to the first power, which is -1. And then -1 divided by 2 to the first is 2. So we get -1/2 for the first term. And then for n equals 2, we have -1 squared, which is +1, divided by 2 squared, which is 4. Okay, so we get 1/4. And then you do the same thing for 3, 4, and 5. You get -1 1/8, 1/16, -1 over 32. Okay. And then r sub 100 is going to be -1 to 100. And for this, think about it for a sec. So here note, I write this here, right? Here note that -1 raised to an even power will be +1, and -1 raised to an odd power will be -1. Okay. So -1 raised to an even power, in this case we have -1 to the 100th power. 100 is an even number. So we divide that by 2 to the 100th, and then you get 1 over 2 to the 100th. And for this, you can leave the denominator as written like this. So yeah, just you're not expected to evaluate that. I'm not even sure if yeah, I guess the calculator could evaluate it, but yeah, it's like 1.26 times 10 to the 30th about. Okay. Does anyone still need either this definition or this example? Okay. If not, then we'll move on. So let me label that. So next we're going to talk about how to graph a sequence, and you can actually do so using a graphing calculator. So here we're going to graph the sequence u of n equals n over n plus 1. So that was part A in the example on your graph calculator. Okay, so this is going to be, with regard to the t at 84. And let me change the screen share. So as you see here, right, we're going to, let me restart this. But yeah, you're going to change the mode to sequence. So that's denoted by SEQ. And then we're going to type in the formula, right, n over n plus 1. And then from there we can graph. Okay. Let me see if we can open up this calculator. All right, hopefully this turns on. Hmm. Oh, okay. All right. Sorry. I think it was lagging a bit. All right. There we go. Should work now. Okay. Yeah. So if you go to mode, right, you'll be able to see this option to change it to sequence, right? So here you go down to function. So that's what we normally have, right? Our graph calculator in function mode, right? To graph functions. But now we want to graph sequences. And as you can see, right, there's also parametric and polar. And the last option is sequence. Okay, so we're going to go to sequence, highlight that, press enter, and then we're going to type in the formula. Press the top left button, y equals. In this case, it will be u, but yeah, we'll have n over n plus 1, and then n min is going to equal 1, as you can see from the notes, as well as this calculator here. Right, so that means we start at a sub 1, right, rather than a sub 0 or a sub 2, etc. Okay. Next, I'm going to go to window, just make sure we have proper scaling here. So I'm going to go from 1 to 10 for, so a sub 1 to a sub 10 basically, so we want 10 terms. And then for x min, x max, 1 to 10, and then y min, y max, I actually change it to 0 to 1, so that's a pretty small scale. The reason for that is because, right, just the nature of the sequence, right, it's going to be all fractions, so it's going to be between 0 and 1. So just to get a better view of that, I'll change it to 0 to 1, and then I'll change the scaling to 0.1. Okay. From here, I'm going to graph. You get this sequence right here. And yeah, you see the same thing from, the image from the textbook. Oh, Leo, can you ask your question aloud?
Where do you find n?
Oh, n, yes. N is, so n is going to be right here, right? Like, so these four variables here, x, t, theta, and n, that's just, yeah, it just depends on, which mode we're in, right? So function, parametric, polar, or sequence, right? So you just press this button and then you get n. Yeah, right here, under mode. Okay. But yeah, good question. Sorry, I should have said that. But yeah, again, n is right here. So you just press that and you get n. Whereas normally, for function, we get x. Okay. But yeah, this is the graph. Okay. So yeah, this is just a quick example of how to graph sequences on your calculator. Okay. All right. So yeah, as you can see, it like follows the same like steps as functions, right? You just type in our function, change the scaling, and then plot. But yeah, you just have to adjust for the fact that we're graphing a sequence rather than a function. Okay, does anyone still need this part here? Okay, if not, then next we have recursive sequences. And if you choose to study computer science, you're actually going to have, yeah, there's a, I guess a applicable topic or concept, especially for computer science. Okay, because for coding you can have like recursive functions, for example. Anyways, recursive sequences. Here's the definition: a recursive sequence is a sequence where the nth term may depend on some or all of the terms preceding it. And of course, the most famous recursive sequence is the Fibonacci sequence. And here we're going to find the first 11 terms of the sequence defined recursively by f1 equals 1, f2 equals 1, and f sub n equals f sub n minus 1 plus f sub n minus 2. So basically what this is saying in words is that the next term in the sequence is the sum of the previous two terms. Okay, so the sum of any number in the sequence is equal to the sum of the previous two terms. Besides the first two terms, which are defined for us as 1 and 1, okay, every term after that is defined by the previous two terms. Okay, so f sub 1 and f sub 2, those are given, right? And then f sub 3, that's the sum of the previous two numbers, which is going to be 1 and 1. 1 plus 1 is just 2. And then f sub 4 is f sub 3 plus f sub 2, which is 3, right? And then f sub 5 is 5 because it's 3 plus 2. F sub 6 is 8 because it's 5 plus 3. And at this point, you get the point. It's going to be 13, 21, 34, 55, and 89. So 89, that's 55 plus 34. That's f sub 11. And these are the first 11 terms of the Fibonacci sequence. Okay. And fun fact, this is actually the number of movies that they're going to release in the Fast and Furious series, right? Right now they're up to F9. Is anyone a fan of that movie series? Oh, waiting for them to go to space, huh? I think that'll be F11. Yeah, I personally am not the biggest fan of the series, but yeah, I've only seen like, I don't know, maybe like one of them. um, but yeah, I just remember, man, they said the seventh one was gonna be the last one, and then they just like dropped 8 and 9, like not just asking for our money. Anyways, I'm gonna move on to the next topic, unless someone still needs this. Next part of the lesson is partial sums. Okay, so from here is 4, right, or part 4 of the lesson. So for the sequence a sub 1 to a sub n, the partial sums are s sub 1 is a1, s sub 2 is a1 plus a2. So at this point you should get the pattern right. S sub n is a sub 1 plus all the way to a sub n. Okay. S sub 1 is called the first partial sum, S2 is called the second partial sum, and so on. S sub n is called the nth partial sum. Okay. All right, so yeah, this is just just a definition of partial sums, like what it is. So when they ask for the first 4 partial sums, as they do in the next example, right, we'll know what they mean. Okay, so S sub 1 is A sub 1, S sub 3 will be the sum of the first three terms, S sub 5 will be the sum of the first five terms. Okay, does anyone still need this definition here? All right, if not then, let me finish this last example. So this example will find the first four partial sums and the nth partial sum of the sequence given by this pattern. A sub n is 1 over n minus 1 over n plus 1. Okay, so as we saw, the first four partial sums are going to be denoted by S sub 1, which is, we just plug in 1, right? So that'll be 1 over 1 minus 1 over 2, right? So that's just A1, right? So the first term in the sequence is A sub 1, which is going to be 1/2. And actually leave it like this because we're going to use that to find S2 and S3 and S4. Okay, S2 is going to be A sub 1 plus A sub 2. Right, so let me actually write that. And this is A sub 1 plus A sub 2. So A sub 1, as we saw right here, we solve, this is 1 over 1 minus 1/2. And then A sub 2 is, you plug in 2, where we get 1 over 2 minus 1 over 3. And as you can see, right, the middle two terms, right, negative 1/2 and 1/2, they're going to sum to 0. So we end up with 1 minus 1/3. Okay, so that's the second partial sum. The third partial sum is A sub 1 plus A sub 2 plus A sub 3. Okay, and that is going to be 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 minus 1/4. Okay, so just using, just using this, right, this part. This is A sub 1 plus A sub 2, which is here, and we add in A3. As you can see, right, the middle terms, the terms in the middle, between, the first and last numbers, they're going to sum to 0, right? Negative 1/2 plus 1/2 is 0, negative 1/3 plus 1/3 is 0, and we're going to end up with 1 minus 1/4. Okay, so hopefully by now you should see the pattern, right? It's going to end up with 1 minus 1/2, 1 minus 1/3, 1 minus 1/4, and then S sub 4, here we can take S3, which is A sub 1 plus A sub 2 plus A sub 3, right here, and then from here we add in A sub 4. Okay, A sub 4 is 1 over 4 minus 1/5. Okay, and just like the other three, or the other two partial sums, I guess, the middle terms, they sum to 0, right? So negative 1/2 plus 1/2 is 0, negative 1/3 plus 1/3 is 0, negative 1/4 plus 1/4 is 0. So we're going to end up with just 1 minus 1/5. Okay, so these are the first four partial sums, and then the nth partial sum is right here. Okay, that's 1 minus 1 over n plus 1. So that's the pattern that we can see, right? So S sub 1 is going to be 1 minus 1 over 1 plus 1, right? S sub 2 is 1 minus 1 over 2 plus 1, right? So that's the pattern that we can see, and from there we can write this formula. All right, so the nth partial sum is this. Okay. All right, let me close with announcements. For only two things. Well, two things today. One, there's SGI 247 as usual. Secondly, as I announced last week, our next and final quiz is going to be this Friday. I put the topics list on Google Classroom over the weekend. Okay. All right. Other than that, you are free to go, and I'll see you all tomorrow or in SGI. All right. Take care and have a good day.
Thank you.
Thank you.
All right. You're welcome.